What I've got here is something from close to my heart, from my childhood. It's the spot the difference and similarity games, right? There's a grandma and for a granddaughter eating or making a cake or something, and they want you to find the differences and similarities between them. I'm not sure if you can make it out, but I was always really bad at these ones, and over the years I've gotten a lot better, practice, and I can see, over here, you got these two bananas, but this one has two, this one has three. Can you guys see anything else? Not sure if you can make them out, it might be a bit small. Yeah, another one. There are these, this cat, it has a spoon here, and there's a lollipop there. Yeah, I guess I'm not that much better, hey? Oh yeah, the clock's at different times. And so initially when you look at them, they look like they're the same. But when you examine it a bit more closely, you realize there are subtle differences. And that's going to be the case when we look at this next idea here. Anytime you're using the quadratic formula, what you're actually doing before you use it is you're comparing your quadratic equation that you're given. So in this case, let's say we have 3x squared minus 2x plus 5. And we're comparing with the general formula, ax squared plus bx plus c. And when we compare them, we can easily say, Callum, what would a, b, and c be equal to in this case? Yeah, too slow. A, b, and c would be, in this case, a is 3, b is minus 2, and c is equal to 5. Okay, so that's pretty easy. When we have it in that form, it's really clear. So, what we can take away from that is, if two quadratic expressions are, we say, equivalent to each other, then look at what you're doing, right? You're comparing. What are you comparing? You're comparing the coefficients of these terms, right? You've got x squared and x squared. Well, obviously, if this is equivalent to this, then a must be 3. If I'm comparing the coefficients here with these x terms, then b must be 2. And the constant then, c, must be 5. So then we say the corresponding coefficients must be equal. Okay. So if the quadratic expressions are equivalent to each other, then the corresponding coefficients must be equal. And you guys have just been doing that for a whole heap of time without even realizing that was a thing. So you may be thinking, well, what's the point of introducing this as a concept? The problem comes when we look at something like this. For example, find values for a, b, and c if 2x squared minus 3x plus 5, so that's our quadratic expression, is equivalent to a outside of x minus 1 all squared plus b outside of x plus 1 plus c by itself. Okay. This is also a quadratic expression, but it's a bit more involved, there's a bit more going on. So, they're telling me they're equivalent, just like in that case over there. And so I want to find values for a, b, and c. Initially, the first thing you might want to do is say, okay, well that's easy then. I'll just do what I did over here. I've got a is 2, b is minus 3, and c is by itself, so that's 5. Have a think about why that's not quite the case. The reason why that's not quite right is, remember, what are we actually doing? We're comparing corresponding coefficients. So we're looking for the coefficients of x squared, but actually what you've got over here is not x squared. You've got x minus 1 all squared. And we're comparing coefficients of a single power of x. But what we've got over here is not that, it's x plus 1. Over here we do have 5 and c by themselves, but we'll soon find out that c is not equal to 5 for that very specific reason for those two before. Because those are not the corresponding coefficients, we can't assume that 5 is going to be equal to c. Okay. So let's think about it. Remember, the goal of this is to find the values for a, b, and c. We already know they're equivalent, they've already told us that. So what we want to do next is, we want to think, okay, how can I get this quadratic expression so it looks more like this? We want some similarities here. We want to think back to when I was looking at that picture. I want to get this to be similar to this. Right there, no, they're not. Right. So have a think. What we can do, because we know that they're equivalent, if I could, for example, get some coefficients of, so remember the goal is to get coefficients of x squared, x, and the constant. The constant is just the one by itself, the term by itself. What I can do is I'll go back, I'll start off with this expression here. I've got a outside of x minus 1 all squared plus b outside of x plus 1 plus c. Remember, I want to find the coefficients of x squared, x, and the constant. So what I can do is, I notice I have here a quadratic expression. I can actually expand this. Let's see what we get. So we get a outside of, for this bad boy out, you get x squared minus 2x plus 1 plus b outside of x plus 1 plus c. Okay, how has that helped us? Well, we've actually got an x squared here, don't we? So, I can start to see what's happening. If I continue to expand, what I'm going to get is a much longer expression, but it's going to get me closer to my goal, find the coefficients of these terms here. Let's keep going. So let's expand this whole expression out. I've got ax squared minus 2x, minus, just want to be careful here, minus 2ax now, because I'm multiplying a by all these terms inside the bracket, plus 1 times a, which is just a, and then I'm multiplying out this guy, so I've got bx plus b plus c. Okay, now we're getting a bit lost because it's so long, but we're actually getting really close now because I can already see one of the coefficients. Right now, in this whole expression, there is only one x squared term, and that is ax squared. So I can already tell from here, ax squared and 2x squared are going to be equivalent. Now there's a difference between over here what we had, which was not x squared by itself. When we come to here, I now do have x squared by itself. Well, I'm not quite done yet, because remember the goal is to find values for all of them, not just a. So I need to think about what I can do about the other terms now. I can see now, actually, a, b, and c, these are going to be just values, right? These are just going to be constants. So what I can do is, let me just group them and arrange them so it's a bit more clear what's starting to happen. So I've got ax squared minus 2ax plus bx plus a plus b plus c. We now have these kind of three groups going on. We've got this group here, the ax squared group. We've got this group here, the x term groups, and this group here. Just the constants, a, b, and c. They're just going to be numbers. So, remember, come back to this idea. If two quadratic expressions are equivalent, which we know they are, they've told us, then the corresponding coefficients must be equal. So I can say now, this is going to be a bit easier. I can say, well, ax squared, I already know that's, well, I can write by itself. This minus 2ax plus bx, I'm not really sure what's the coefficient of x, because I've got these two x terms. What I can do is, I can factor them out though. Because my x terms are in common, I can take a factor of that out, right? So I would get left with, if I took out positive x, I would get minus 2a plus b, okay? Because if you expanded these out, you get the same thing. And I can leave that as it is. And that's now helped me find the coefficient of the x term. That's just going to be plus minus 2a plus b. So I've just rewritten it in front of the x term, so you can see that's clearly the coefficient of x. Okay. How does that help us? Yeah, you can see that. Now, that lets me easily compare these two expressions. I have, on the left-hand side, it said 2x squared minus 3x plus 5 is equivalent to, ax squared plus negative 2a plus bx plus a plus b plus c. So I had these three groups going on. And so now I can clearly say, well, a is going to be equal to 2. What is negative 3 going to be equal to? look closely, right? You want to compare your x terms. You can see that the coefficients are going to be equal from that concept over there. So I know that now. Negative 2a plus b is the same as negative 3. And then this last constant group here, a plus b plus c, is going to be equal to 5. So I've got one piece of the puzzle. I've got a equals to 2. That's awesome. What do I want to do next? Well, I want to find the rest of it here. So let's keep going. If I want to find now what is b going to be, I can say, well, if I know what a is, I'll sub a is equal to 2. And then I'll say negative 2 times 2 plus b is equal to negative 3. And I can just multiply this guy out. I've got negative 4 plus b equals to negative 3. And so b is equal to positive 1. Awesome. How can I find the last piece? Well, I know that a plus b plus c is equal to 5. I already know a and b. So I can just say, well, let's sub in what we know. We've got a equals to 1, b equals to, a is equal to 2, b is equal to 1, and then I go back to this equation. Let's fill in the pieces that we know. I know that 2 plus 1 plus c is equal to 5. And then if I want c by itself, I'll just subtract 3 from both sides. So c is equal to 2. So remember, don't forget the original goal of the equation, right? It was saying find values for a, b, and c if this quadratic expression is equivalent to this one. And that's exactly what we did. Okay? If you substitute in those a, b, and c values into your equation back here,